We're ready to rock and roll, huh?
Great.
It's all yours, my friend.
All right. Well, I want to thank you for inviting me to give a talk to the East Bay Astronomical Society. Thank you to Richard and Dave and Andy and those who have helped to set this up. And I'm going to be talking about the Messier Marathon tonight. You can reach me at dontheastronomer@gmail.com. And I also have a website, donmacholz.com. I put out a podcast every week, and I have for the last 2 years. Podcast number 5 to 11, which you can find on my website, donmacholz.com, discuss specifically the Messier Marathon. All right. You only need one telescope for this, or binoculars. Now, some people are a little put off when they hear about a Messier Marathon. Many amateur astronomers have not even seen all the Messier objects, let alone try to find them all in one night. But believe me, it is possible to do, and a lot of people do it. And some astronomers say, you know, I just want to do it at least once in my life, be able to find as many Messier objects as I can in one night. From certain latitudes, you cannot even see all 110 in one night, but just to do as many as you can from wherever you're located with whatever skills and instruments you have. That's an accomplishment. And I've always looked at it that way. No matter how many you find as you complete the Messier Marathon, you've done well. Now, Charles Messier was a comet hunter who lived more than 200 years ago. In fact, his 300th birthday is coming up in about 8 years. And he worked out of Paris, France. He was good at making maps. He was a map maker. He also was able to organize things. And it takes someone like that to do what he did. He had an interest in finding Halley's Comet when it was predicted to come back. And he began searching in late 1757, and he was given positions as to where to look. And they weren't as accurate as they could have been, maybe, because someone else found Halley's on its return visit before he did. And his observatory delayed a few months, even announcing that Messier had picked it up about 60 days after it had been recovered. But he began still searching for comets around that time. Paris Observatory is where he was at. Here it is at different time periods. There was an observatory there with telescopes. And the telescope he used most would be a 3.5-inch refractor, 3 feet long, so it was about an f10, with a magnification of 120. And it did not have really the best optics. Most of your telescopes are much better than that. As some of the open star clusters he looked at, he thought he saw nebulosity among the stars, when in fact we know there wasn't. Another telescope he used was about a 6.5-inch reflector, but it had a metal mirror which reflected the light. It wasn't a coated mirror. I mean, that's what they had back then. And it did not always give very good images. Now, he visually covered 13, but 12 of those comets bear his name. It was in 1760 when comets first began to bear the name of the discoverer. Maybe based upon that, or maybe based upon the fact that Messier took it to task to find comets, but competition among astronomers to find comets kind of began around then, 1760. The first comet found with a telescope was found 80 years earlier in 1680, and between those two times, almost no one found comets with telescopes. In fact, when we look at these 13 comets discovered by Messier, 12 of them have his name. One of them has the name of Lexell, Anders Lexell, who determined the orbit. And there's 4 comets that have the name of the orbit calculators rather than discoverers through history. But on the far right, we have the instruments he used, either telescope or the unaided eye. And then we have the locations and dates that the comets were found. Elongation, EL, is degrees from the sun. And we can see he swept all over the sky. The furthest south he ever found any comet was minus 16.5 degrees. And he did sweep pretty far north. He found a few of his comets in January out of proportion to the rest of them. Now, Charles Messier was the first person, therefore, to visually discover 12 comets that bear his name, and that was beginning 262 years ago. The hobby of visual comet hunting is more or less coming to an end. In fact, many of those who visually found comets in the late 1970s, 80s, 90s have dropped out of comet hunting because of those government-sponsored sky surveys that are now finding most of the comets. We went 8 years before we found the last visual comet discovery. That was one I found in 2018, and it's been 3 years since then with no other visual comet discoveries. In fact, there's probably about 3 or 4 people around the world still visually searching for comets, and I'm one of them. I'll probably be the last person in recorded history to visually discover 12 comets that bear my name. Now, Charles Messier, as he did his comet hunting, stumbled across fuzzy objects that appeared like comets. When you search for a comet visually, you're looking for a fuzzy object. You're not looking necessarily for something that moves. It will move, but the first indication that you have a comet is that you find a fuzzy thing. So when he was looking at the comet of 1758, he wasn't actually hunting at that time, but he was looking at that. He picked up the Crab Nebula, which became M1, and then a couple years later, M2, and so on. He then published these in catalogs. The first catalog had 45 objects, and it was a lot of easy stuff, bright stuff, things that were by others. Charles Messier made a few mistakes in some of his catalogs, objects with positions and stuff, but he did far better than most of the astronomers who went before him. De La Salle of the Southern Hemisphere had some difficulty with some of his positions. And what Charles Messier did was to look at some of the objects that others had plotted to get a more accurate position and to get a description. And then he would include them in his catalog and credit to the earlier discoverer. And then his second catalog came out a little bit later, and it had more difficult, fainter objects and a lot of galaxies. Some of these objects have been in dispute or are somewhat misunderstood. We do know that M24 is actually a whole star cloud. It's about 1.5 by 1 degree across, and that cloud itself is M24. Now there's a tiny star cluster known as 6603, open star cluster, but that itself is not M24. The whole star cloud is M24. M40 is a double star, and it's off of the middle star in a handle of the bigger, a few degrees away. Now, Messier had heard that there was nebulosity between stars, and so he wanted to see for himself, and he looked at it and he says, well, you know, it's a couple stars, but I'm going to put it in my catalog in case anyone runs across it, and they might think there's nebulosity. No. M73 is actually 4 stars. And it's 4 unrelated stars. They're not really actually a cluster, but a star asterism. And then not mentioned in these slides, but 2 other objects, M47 and M48, he had the wrong positions for those 2 objects. In M47, he was 5 degrees off, and he might have used the wrong line of declination to measure it off of. And for M48, he plotted it in a position where there doesn't seem to be anything, but we're pretty sure we know what M48 is. Now, M91. M91 was considered to be a missing object until the 1960s. And until recently, I still had my doubts, but I think it's pretty clear what happened with Charles Messier on this object. All of the objects here from M84 to M91 were plotted and described by Charles Messier on the same night. And he said that M91 is up in this area here. In the mid-1960s, a guy named Williams of Texas wrote to Sky and Telescope with what seems to be the solution. Prior to that, people thought, well, maybe this was just a passing comet coming through. And Messier assumed it was a galaxy, looked at it one night, didn't see any motion, and just assumed it was a galaxy. But instead, the thinking is that when Charles Messier measured the position for this object, he thought, he used M58. And instead, he should have used M89. And if he had gone, well, he used M89, but he thought later he was using M58. So the distance between these two objects in the direction is almost exactly the same to within a couple arc minutes. Now, there's some problems with this theory, because as we go from right to left, the numbers increase. 84 here, 85 up here off the picture, 86, 87, 88, 89, 90, 91 ought to be there. But instead, and the other thing is M89 is not a real bright galaxy. M58, how come he got those two mixed up? It had been a few years since he had cataloged this one. So maybe he had kind of forgotten how bright it was or whatever. But if he was measuring off of this one instead, we do have a galaxy right there that was within reach of his telescope. And the general consensus, and this now seems to be non-debatable, is that M91 is 4548. M102 has been a mystery for centuries, because Charles Messier probably observed it, but it was his assistant who picked it up, and it seemed to have been misplotted on his map. When his assistant, Pierre Messier, tried to find it later, he had difficulty finding it, and he could not find it again. So he made the assumption that it was just a duplicate observation of M101. Here's the handle of the Big Dipper. 101 is here, and a galaxy known as 5866 is over here. Now, we have pictures of both of these, and you can see there seems to be a difference between them. How could you confuse those? I'm thinking that when Messier went back out to the sky and tried to find M102 again, he had the wrong position because it was misplotted incorrectly on Messier's map. He could not find M102, 5866. So he just made the assumption, hey, I must have just looked at M101 again. The descriptions for each is different, and the location description for each is different. This one is referred to as being near the Big Bear. This one's referred to as being near Draco, which is up here. And so most astronomers who have studied this thoroughly have come to the conclusion that M102 is 5866. Sky and Telescope magazine does not accept that. Steve O'Mara has written about that a few times. He doesn't accept it. So that's why when you read Sky and Telescope, they talk about the 109 Messier objects because of this one. M110. Now, M110 is a satellite galaxy of M31. Here's a picture of M31, the big bright one, the M32 a satellite. And then we have M110, which is another satellite galaxy. Now, Charles Messier did not make M110. He did make a drawing of galaxies. What does drawing show? It shows that. It shows M31 here, M32 here, and M110 here. In fact, it moves up well. So a guy named Glenn Jones. Quite a guy. He wrote the Messier's nebula and star clusters. He was an expert on Charles Messier. In the late 1960s, he suggested that or the companion galaxy of M31, and the companion is NGC 205. So that was his suggestion, and that has been accepted in the Messier Catalogue. Everybody for astronomy magazine. Astronomy magazine says there's 109 Messiers. They accept M102, but they don't accept M10. Now, these objects are scattered throughout the heavens. Here we have north to the top, south to the bottom, and the equator running across it over here. We have the Milky Way objects here in the Milky Way, the winter Milky Way, center of our galaxy.
Hey, Don, you there?
Yep, I'm here.
Okay, sorry, you dropped for a minute.
Okay.
We can continue. Thank you.
Okay, here we are. So we have here a map of the heavens. We have a lot of galaxies here where we do not have the Milky Way. And we have the Milky Way running along this way, where we have open star clusters and nebula, and globular clusters. A lot of them are toward the center of our galaxy. And as the sun moves along through the sky, it passes by some, others it never gets close to. And as objects, as every day passes, an object will set about 4 minutes earlier in the evening and rise about 4 minutes earlier in the morning. So we lose objects in the evening sky and we pick them up in the morning sky. And throughout the whole year, there are times like here, when the sun is here, that is obscuring the fewest number of Messier objects. Now, I began comet hunting systematically in 1975 and doing hundreds and hundreds of hours, and you sit out there looking through the telescope, what else are you going to think about? I thought a lot about the Messe objects, and that it would be possible to be able to see many of them during certain times of the year. And I came up with an idea about maybe doing a marathon. When you look in the evening sky mid-March, we have M33, 110, and 32 over here, 33 over here, and M74 down here outside the picture, M77. They're all setting in the western sky. And if we're to look at a star map of the western sky, this whole sky, this whole circle is the sky. This is the zenith overhead, and this is to the west. We see some objects, and then objects move this way and set in the west and rise up in the east. And the morning objects now have moved all the way across the sky, those galaxies, and some new objects have come in, including stuff along the center of our Milky Way and the center of our galaxy over here. So I began working on that and put together an article for the San Jose Astronomical Association. And here I said, hey, let's do something called the Messier Marathon. And I suggested the 107 objects. Now, there was an organization back then, I don't know if it's still there, and it's called the AANC, Astronomical Association of Northern California. And they were giving out a certificate if you could find all 107 Messier objects. Well, how do they come up with 107? M91 was still considered a missing object, M102 was missing, and M110 had not yet been suggested. So they said 107, but now we talk about 110. And I suggested that spring of 1979, we all get together and do the Messier Marathon. And lo and behold, March of 79 comes, and this article ends up in Sky and Telescope magazine. Walter Scott Houston, who was a deep sky observer and who wrote for Sky and Telescope each month, wrote an article about something called the Messier Marathon. And he talked about some of the, there's Walter Scott Houston there in his later years. And he wrote, and this map was there in that issue of the magazine. And here we have the evening twilight. You're facing the west here, and you do have some of those objects as they begin to set. And then in the morning sky, this is your horizon in the east. And you have these objects beginning to rise. That makes a lot of sense. I wrote an article for Astronomy magazine. I asked if they would be interested, and they said, go ahead. And I thought maybe it would be a feature article. And they said, no, we'll just put it in the forum section. Nevertheless, I got to talk about it, and I had put together by then a observing order. That same observing order now thousands of astronomers use, and it seems to make a logical sense. Here are the founders of the Messier Marathon. Tom Ryland kind of began it with 86 objects, and the objects in red means that was the first time that many objects was observed in a Messier Marathon. And you can see how it progressed through the years. It was the late Jerry Ratley from the Bay Area who moved to Arizona in the 1980s, who was the first person to pick up 110 objects in one night. There might be some other people who helped to develop the Messier Marathon even before this. Walter Scott Houston wrote me that after he published his article in Sky and Telescope, he received a letter from a group in Spain that said, hey, we've been doing this thing for years. So there were several people who came upon the idea around the same time. Now, in order to do a Messier Marathon successfully, there's a few things that really help out. One, you do not want a lot of light pollution. People have done it in light polluted skies. The main issue is that you have dark skies, mainly in the west and in the southeast. If you have some light pollution to the north, you're probably okay. Number two, we do want to avoid the full moon. The moon tends to wash out objects. Not so much for you astrophotographers out there, but for the rest of us, visually, the moon can cause a problem. However, I will explain in a few minutes how I once did the Messier Marathon when the moon was just 3 days past full. So yes, you can do it. And if it gets down to even be a crescent, you have to be careful, because even a 30% lit moon near M1, which happens in March, is enough to wash it out and make it difficult to see some of those objects. 3 factors will determine how well you can see: your eyes, the skies, and the telescope, probably in that order. I suggest that people practice. They learn how to use their telescope and become familiar with the field of view with their telescope. And the more you look, the more you'll see. The skies are important, and also the telescope. A larger telescope will do better in the Messier Marathon than a smaller one in seeing the objects. For finding the objects, a wider field usually works better. Now, can people use setting circles and electronic setting circles and go-to telescopes to do the Messier Marathon? Yeah, they can, and they do. And I discussed this with some of the other guys who put together the Messier Marathon back in the 80s or early 90s. And we kind of came to the conclusion that you can't stop it. If we were to say you can only do the Messier Marathon if you star hop, you're going to lose a lot of people. So no, you can use a go-to telescope. And I did that for the first time a few months ago, used a go-to telescope. And yeah, it's easier that way. But you know, star hopping has its benefits too. The reward of actually finding the object. The important horizon will be due west and northwest, and then also southeast or east-southeast. The day of the week is good, is important. Some people want to do it only on the weekends, and Saturday nights are kind of top night for astronomy clubs to get together and do stuff. And yeah, I do it almost any night of the week. In fact, I prefer weeknights are fine for me too, and for others too. Now, what latitude you're at does matter. The further north you go, the more objects you lose. In fact, if you are, and this list here is a bit on the pessimistic side. If you're really good at what you do, you can actually do better than these numbers. But these are the number of days in which this many objects are visible. You get up there near 50 degrees and you can never see 110. You move down a little bit further south, around 40 degrees, and you get close, but not quite. Although if you have an exceptional night from Colfax, I just missed 110 from Colfax at 39 degrees north 1 year. And I had exceptionally clear skies. I actually missed, I think, M72 and M72 because I couldn't see it, but I got M30. Now you move a little bit further south at 30 degrees north, and you begin to have more nights in which you can see 110 objects. The sweet spot is around 20 degrees. Move further south and not quite so good. And when you get down to the equator, you know why you can't do 110 in one night? Because of M52 and M103. Those are so far north, and they're just north of the sun. So when the sun sets, they set. When the sun rises, they rise. These are the Messier Marathons that I have done. I've started over 60 and completed 50. The ones that are in red were clouded out, and so I wasn't able to do it for the full night. Here we have on the far left, the number, the date, the number of objects I saw, Messier objects I saw, the location, the instrument, and then the missing objects and notes. 1 year I used only audio tapes to tell me where to look, no charts. And I also did something known as the Massive Marathon in 1981, finding 599 objects in one night using no setting circles and a lot of star maps. And one object every 52 seconds for over 10 hours. That was a long night. Then I moved to Colfax in 1990 or so, and then I would begin to go down to Joshua Trees Park, or a place, Joshua Trees, or a place called Red Cloud, which was down there, and also the All Arizona area for the ones in Arizona. I began doing them from memory, in which I use no star charts. And sometimes I just use a blank sheet of paper and just wrote them all down as I saw them. As time goes on, it got easier for me to do them. Now I've done them in other months, here early April, June, February, April, December, and you can do it any month of the year and get at least 92 objects from mid-northern latitudes. For the first time, I used setting circles in last December, a few months ago. There's other types of marathons that can be done. The photographic Messier Marathon. A few years into the marathon, people began to actually photograph them. And I remember 1 year they got most of them, and then a couple of years later, somebody was able to photograph all of them, or using CCDs. You can try with the unaided eye. You won't see them all, but it's probably a little bit faster. Binoculars, people have done that. And then you can do mini Messier Marathons. You can do them 2, 3, 4 times a year and see 25 objects each time. And in the course of a year, then see all of them. You can do them from the city, which is a bit more challenging, or you can do the planets and the Messier objects. You cannot do all 9 planets and all 8 planets and all 110 Messier objects in one night now, because in late March, you're missing Uranus and Neptune. Give it a few decades and they'll pop out again in late March. You can make your own marathon of planetary nebulas, or go through a whole bunch of objects in a certain constellation, or globular cluster night. Do the massive marathon. The Herschel marathon, and I have the charts for that in the observing order, but I've never done that. The week I was going to do it back in the 80s, it was cloudy all week, so I never did that. The Caldwell marathon uses the 110, 109 Caldwell objects put together by Patrick Moore, and they are both north and south. And as I determined in one of my books, you cannot even do it if your twin brother is in the southern hemisphere and you're in the northern hemisphere on the same night, only because there'll always be something near the sun. There is a search sequence widely distributed. You can also get it on my website under Looking Up with Don podcast. I always have downloads for my podcast, so you can go to my website and get star maps every week that are different. And I began making a book of maps on how to find each object in the early to mid 1980s. I did this. And then I would take this out with me each year and make notes and corrections and changes. And then I began writing books, including the first one was well, that was the first one there, never published it. And then I self-published the Messier Marathon Observer's Guide, Handbook, and Atlas. And that was in 1994. And then Cambridge came along and did one in 2000. It's also been translated into Spanish. You can buy a reprint, actually the first edition reprint from me, but email me at Don the Astronomer and we'll figure out the shipping costs. They're $35, and if you want, I'll autograph them for you. Now, this year, 2022, we try to avoid the moon, and we try to find a Saturday and Sunday. And the best we can do is on the March 26th, 27th. Now, the moon will be in the morning sky, so the evening sky will be dark. March 26th, 27th, you will have trouble with M74 and M33 and M110. All those objects are a bit diffuse and they're low in the western sky. The morning sky, you will have trouble with M30, which is a globular cluster, and it's the last one to rise. Everybody will have trouble on March 26th, 27th, unless you live pretty far south. Now, the moon will be 25% full in this part of the sky. And we have one bright planet, Venus, nearby, Saturn and Mars. There you go. M75 will be the object closest to the moon, but M75 is a compact globular cluster. You should probably not have any trouble seeing it or finding it, even though you've got a 25% moon in the sky. The problem could be M72. Now, M72 is a globular cluster too, but it's diffuse. It doesn't have a very bright center, and it's a little difficult to pick up. So the moon may cause some problems with M72, and then you've got M30, which will rise around the time of astronomical twilight. So those are the conditions we have this year. Next year will be a little bit better. About every third year, we have an ideal year. And every other third year, we have a pretty bad year with a full moon during that week. And then every other third year was so-so, something like this. Now, sometimes golfers, professional golfers, when they're going to play a course, they go out and walk through the course to see what it's like beforehand. In cross country in high school, that's what we sometimes did on a cross country course before we ran it. That's what we're going to be doing here over the next 15 minutes. We are going to be walking through the Messier Marathon. It won't be as scary as you might think. So we begin facing in the west, And we begin with M77. Why? I used to begin with M74 because it's set first, but M77 is the ideal one to start with. It has a high surface brightness. It's not involved in the zodiacal light, and it can be picked up while it's still twilight. All right. So you begin with M77, come on over to M74, which will probably be your most difficult object. It will be probably fewer than 10 degrees off the horizon, and it's a 9.5 magnitude galaxy face on. M33 will be your next object, a large galaxy, but not very bright. And then we hop over to 31, 32, and 110. And then we've picked up the most difficult objects in the evening sky. If you can get all 6 of those objects, you've done great. We continue working from left to right. We hop over and we hit M52, M103, and then down to M76, the little dumbbell nebula, one of the fainter objects and tinier objects, and then up to an open cluster, M34, and then M45. Now, a note about M52 and M103. If you fail to pick it up in the evening, you can pick it up again in the morning. I like picking it up in the evening. It fits in with the sequence, doesn't fit in well with the morning sequences. And if you get clouded out or get way behind, better to get it now in the evening than to have to push it into your schedule in the morning. Next, we head south, and we're going to hang in the south for a little while. We go next to M79. Now, this is a globular cluster, and this will be setting in a while. So you want to find that. Come up to the Orion Nebula, M42, and M43. Don't forget M43. You got to see that one too. It's a little appendage of M42, and then M78. And we're going to continue moving to our left and pick up these open star clusters. We have 6 of them here. And then we head north to M1, where it all started, and then 35, then 37, 36, 38. And then very high in the sky by now, M44 and M67, 2 open star clusters. I know a lot of people are a little bothered by this area here with all these galaxies. We're going to ignore that for a while. We'll get back to that in a few minutes, but instead we're going to cover a lot of things around here while this rises higher in the sky. We have in Leo, we have 3 galaxies here and 2 more here. And then we swing over to the left, fairly high in the sky. This is really high up, not quite overhead, but M81 and M82, and then on down the Big Dipper, including including down to M101, 102, and then these objects here, 51, 63, 94. And then we're going to drop down here to this area and get M64, 53, which is a globular cluster, and M3, which is also a globular cluster. So now we've done all these objects here. Our next area is an area filled with galaxies. And I know that there's astronomers who get upset about doing this, a little bit nervous perhaps, because all these faint galaxies here, you can get them mixed up and you can get lost. And I've seen people do them in 2 minutes. I've seen people do them in 2 hours. I've heard of people who have given up halfway through and say it's impossible. It is possible to do all these objects and to get them done in 10 or 15 minutes. It's not really that difficult. 2 reasons. One, these Messier objects are the brightest galaxies in this region. So when you see a bright galaxy, begin thinking, oh, this could be the Messier object I'm looking for. If you hop over and you just see a faint galaxy, that's probably not it. The other thing is they're so close together. Instead of star hopping, we're galaxy hopping. Now there's 3 ways to approach this. And I have seen in search sequences done by others, I've seen all 3 done. One is you start from Leo, go over to this star, which is number 6, and work your way around. Okay, that's one way. Another way is to start at this star in Virgo, come back up this way. Now you're moving away from the eastern horizon and work your way through this way. The advantage here is you begin with some bright galaxies. These are some of the brightest ones in the whole group. These are some of the famous ones in the whole group, okay? And the third way is to find these two, which is a distinctive pair of two galaxies almost identical, and then head up here and hit these objects, these, and these. Always coming back here to this landmark that you can find. And this is 10 degrees here, so you're not moving your telescope very far to go to each of these branches. The way we're going to do it is this way. We're going to start here and work our way around. I've done it this way. I've suggested others have, and it seems to work for just about everybody. We start at the bright star Denebola in Leo, comes 6 degrees over to star number 6 here. And this is where we take off from. We go back about a half a degree to M98, down to 99, up to 100. M100 can be difficult. It's a face-on galaxy, kind of diffuse. Continue up north to M85, and then drop due south about 5 or 6 degrees to M84 and M86. You'll know it when you see it. Those two really stand out. From there, we go around the horn, M87, 89, 90, jump up to 88, 91. Now watch this. As we head back down, we cross over M90, go an equal distance to M58, 59, and M60. So we do this type of loop here. And the difference from here to here is only 2 degrees. If you have a field of view of 1 degree, this type of star hopping can be fairly easy, even in a Dobsonian telescope. Now, we're going to head back away from the eastern horizon, higher in the sky, head south a little bit to M49, M61, and M104. Then we drop down to M68, and a little bit later, M83. M83 is kind of in the middle of nowhere. I usually wait till these stars rise. And when I do the Messier Marathon, almost always, for the last 40 years, I'll do a bunch of objects in the evening, and I'll end up usually with M68. And that will be the last object I'll see in the evening. And then I usually go to bed, and I'll sleep for 6 hours. I'm in bed usually by 10:15. I get up around 3, and then I pick up where I left off. And by then, M83 has moved over to this part of the sky, and you pick it up and continue on. So you've got about 66 objects so far of the 110 objects, and we're only 2 hours after astronomical twilight. So in the first 2 hours, you've done a lot. Now, you don't have to do them that fast. And some people will take all night to go through them and spend a lot of time observing each one. Even if you spend 5 minutes observing each object, you can still do all of them in one night. We wait a little while for some things to rise, and then we get some globular clusters. M5, one of the brightest globular clusters, M13 and M92. This is now facing the east. Objects are rising. M57 and M56, 29, which is a tiny, M29 is underrated in my opinion. We show that at public star parties. People like M29. It's just a little group of 7 stars, but it looks good and it has a nice background. And then M39, which is a rather large open star cluster. And then we come on over to M27 and M71, which are just shortly after they rise. Then we have some globular clusters to hit, M12, M10, and M14. And then we head south for M9 and M107. Now we're going to head over to Scorpius. By now it's probably 3 o'clock in the morning, and this has significantly risen above your southern horizon. If you're doing this from Canada or Washington State, your horizon will be a little difficult down here, and you have to wait a little bit longer for them to rise. But we start with M4, which is right near Antares, hit M80, 1962, 6 and 7. M7 is the southernmost object we're going to hit. And from Paris, M7 was no more than 6 degrees above Messier's southern horizon at any one time. So he picked up that object only 6 degrees off the horizon. This is my favorite sequence, where you ride right down the back of the Milky Way. And boy, do we have a lot of variety of things to see on this one. Began at M11, which is great through a big scope, looks pretty good through a medium scope. Down to M26, not that great. M16, 17, 18, 24. From 24, we go see 25, 23, and then 21, M20, the Trifid, M8, the Lagoon. By the way, a few years ago, I tried doing the Messier Marathon with the moon along the ecliptic in this area. And that was really difficult. The moon was about 30% full, but it was enough to make, I finally did find M8, but I didn't see much nebulosity in it. Same with M20. I saw mostly the stars. And then M28, and then the bright M22. Now we move into Sagittarius. We've seen 100 objects so far. We're down to the final 10. And these will be low in your southwestern horizon, 69, 70, 54. Now, M55 is a big, bright globular cluster, not so much in twilight and low elevation. But you will see it. And when you see it, you'll notice, and oh, that's it. It will stand out once you pick it up. And there's nothing very bright nearby, so you do have to sweep around to see it. And then we have this kite-shaped asterism. I usually go on over there and head due north from there for M75. Now we still have some stuff in the north to pick up, which have risen in the last hour and a half. M15, not too hard, dropped due south for M12. And then we pick up M72, M73. 72, as I said, is a diffuse globular cluster, and it will blend in with your twilight. You have to be very careful in finding it. M73 is about a degree away. It's a little bit easier to see than M72. And then our final object is the most difficult one in the morning sky. And when most astronomers do the Messier Marathon and they say, I got 109 objects, you'll probably be right by saying, oh, so you missed M30. It doesn't become easily visible until late March, usually after March 25th or so. From your latitude, March 27th or 28th will be probably the first you'll be able to see it. It gets easier with each morning, but with each evening, the objects in the evening sky get more difficult. So we've done here in the last 10 minutes all of the Messier objects. Do we have any questions? That's the end of the talk.
Don, on your last, this is Dave Rodriguez talking here.
Yeah.
On your last one, you said, I think you said it was M12, but it looked like it was labeled as M2. Did I miss something there?
Oh, M2, yes. M15 down to M2. You're right.
Yes. Okay, thank you.
I don't have a question, but I do have an answer. You asked earlier about the AANC.
Yes.
And the AANC is officially dissolved. It no longer exists as a nonprofit or corporation. But the AANC meetup list still exists and has 1,000 people on it. And it is graciously hosted by the San Jose Club.
Oh, wow. Okay.
So it's a resource for club publicity in the Bay Area, and can send your events out and have it read by upwards of 1,000 people.
All right.
So there
Sounds
is
good.
life after death
Yeah.
after all.
Yeah,
The
this is
ANC was
definitely the ghost of the AANC.
Yeah.
Not to be confused with the Ghost Nebula.
Well, we don't have any questions coming in yet. We do have 32 participants on board, but
Okay.
I did hear from a member of my family who said, and this is a non-astronomer, by the way, a member of my family said it was a great talk and the diagrams are great and it was a great presenter.
Well, thank you. Thank you.
All right, so if folks have questions, put them into the chat window. Let me see if there's any asked on Facebook. Give me a sec here. Don, where are you living now?
Arizona,
Oh,
kind of northwest Arizona, southeast of Kingman, about halfway between Phoenix and Las Vegas, 3 hours each way.
oh, you're in a nice dark area.
It is.
You chose well.
Well, we looked around for a while before deciding to move here.
Oh, you're in a nice dark area. Oh, great. Well, I don't have any questions on Facebook, so here's one. Hold on, we got a couple questions coming in on QA. From Alan, he says, fantastic talk. Don, during your observing Messiers and comets, did you pick up any SN? I'm not sure what SN is.
Supernova?
Supernova, there we go.
Supernova. No, I never have. I do look for them. I mean, when you're comet hunting and you run across a galaxy, you hold it in your field of view long enough to identify it and then move on. But any supernova brighter than 10th magnitude or maybe even 11th, I might have noticed, but I didn't. Jack Bennett, South Africa, discovered a supernova in M83 while he was comet hunting. He discovered two comets, but one was Comet Bennett in 1970.
Oh, yes.
Yeah.
This is a good question. How much of this can be done with binoculars? It sounds like some are pretty faint, and some certainly are.
It depends on the binoculars, the observer, the eyes, the skies, and everything else.
Let's say somebody's using 10 by 70s or something like that. Just a more standard size binocular, not like JMI, sedan sized binoculars.
Well, I've done it with my big blue binoculars, which have more or less a 6-inch aperture, homemade binoculars, and I think I've done 109 objects. But you're going to have some difficulty with faintness, although contrast is improved with binoculars. So don't sell yourself short on it. And the other, so you may have some difficulty, say, with M74, but M33, which is a little bit larger, might do okay in binoculars, as would 110. Now you get to M76. M76 is a planetary nebula about 1.5 arc minutes across. That one might be difficult because it might blend in and look like a star at 10 power or even 20 power. So you may have some difficulty there. Now, those galaxies in Virgo, wait till they get higher in the sky, steady yourself, and probably most of those can be seen with 11 by 70s high in the sky. Not too much light pollution by someone with experience.
All right.
Now, after all that is gone, we move to the morning sky, and that's a bit easier. The morning sky has the globulars. The morning sky has a lot of open clusters and nebula. So the time that I did the Messier Marathon when the moon was 3 days past full, I had about an hour of darkness, and I picked up my first 60 objects. Then the moon came up. So by then I had already done the Virgo galaxies and a lot of the faint stuff. And then the moon comes up, more objects come up, and those objects are the brighter ones. So I was able to see, I think, 109 or 108 that night, even despite a very, very bright moon for most of the night.
I know Marianne is out there. She has a question, but Marianne, I need you to type it into the Q&A section or the chat. We don't have any other way to do. Here you are. Here you are. Oh no, that was Alan. Okay, what in your mind is the most spectacular comet you have seen, and which historical comet would you most like to have seen if you could travel back in time?
Yakataki was good. Short-lived, but it was a bright comet in 1996, March. And I'll always remember this. I was giving a talk in Berkeley on, I think it was March 24th, 1996, and living in Colfax. So I had to get up early to drive to Berkeley. And I got up at around 5 a.m. and it was foggy in Colfax. Doesn't happen much, but it happened. So I go out on the back deck and I look up and I can see three things: the star Arcturus, the star Vega, and the nuclear region of Comet Yakataki.
Mm-hmm. I remember that.
Now, under dark sky conditions, you had a very long tail. Comet Hale-Bopp did a great job, as lasted many, many months and put on a very good show, had an active nuclear region, and that was great. I do remember Comet Bennett, and then Comet West was quite good too in 1975. But I would say probably Yakataki, just for that one experience. Now, if I could go back to any time, the comet of 1744 had the multiple tails, and we had a great sun grazer in 1882, I believe it was. That would have been great. I was alive in 1965 for another sun grazer, Ikea Seiki. A lot of people talk about Ikea Seiki and how it was probably one of the brightest comets, minus 10th magnitude perhaps, when closest to the sun. But and it was that month that I got my first telescope, 2-inch refractor, but I did not know anything about that comet or where it was, so I never did see that. One more comet is Comet McNaught, 2007.
Mm-hmm.
I did see it in the daytime in binoculars, and I could then take down the binoculars and barely make it out with the unaided eye. And it was a few degrees from the sun. I had to block out the sun. And so that was another great comet.
Ask it.
One of our participants himself asked, what kind of telescope do you recommend?
The one that you are most familiar with will work in most cases. I want you to be able to look through the eyepiece and know which way to turn it for things to move this way and that way, for you to know which way is north, south, east, west, up, down, left, right, and for you to understand the field of view and to know about how bright an 8th magnitude object would appear in that telescope and how bright a 10th magnitude object will appear in that telescope. And if you've been using your telescope for a few years, you are tuned into those things. I have been confused at times when I've looked through other people's telescopes and gone from what I use, a 10, 6, or 18-inch, to something bigger or smaller. And you see something, you think, now, how bright is that? Because I'm not used to this, what this shows like through someone else's telescope. So use what you are familiar with. If you have an option, if you're familiar with several telescopes, you can go one of two ways. If you're going to star hop, a wide field of view is good. That usually means a little bit smaller aperture, which is going to cause some difficulty seeing M74, M33 in the evening sky, maybe M110, because a larger aperture will usually show it a little bit better. If you're using a go-to telescope, just about anything as long as it's accurately aligned. And you just, I guess they just push buttons. I had to push my telescope around because it doesn't have motors. But a lot of the go-to ones, you just punch it in the keyboard and it goes right to it.
Well, I know that a lot of our participants will be relieved that they can use the telescope that they have.
Yes.
Somebody's asking, here's a chance for you to do a plug here. It says, also, I think you said you have published a guide we can buy.
Yes. Yes, it was the first book that I self-published, and it is an observer's guide and an atlas on, and it has maps on finding each of the objects. Using the equatorial method, you go from this one, you go south or east or west or north to the next one and so on. And email me because we got to figure out the shipping, and it's $35 and then you pay the shipping, and that's only usually a few dollars. And you actually have a choice. You can get the original book, which is the first printing, which has actually has my name misspelled on the title page, and a couple of grammatical errors, and it has the original observing order. Or you can have the updated one, which I think is about the sixth printing, in which I have since changed 6 of the items in the observing order. After we hit M79, 42, 43, 78, in the original one, we popped up north and got M1 and those open clusters. Then we went back south again. And about 2 decades ago, I thought, wow, this is kind of redundant to do that. While we're doing those things in Orion, let's move over and do those other things. And then we pop north. And so the observing order changed slightly back then. And so that's the other addition.
Okay. Going back to Joe's question earlier about binoculars, there is a book called Binocular Highlights, which gives you like 99 easy to find objects in the night sky. And some of those are Messier objects. So we hope that helps. But of course, the book is not nearly as good as your book, Don.
Well, thank you. Thank you.
Let's see. What is there? Well, is there an ideal field of view that you recommend?
Yes, having at least 1 degree field of view will help with most telescopes, because especially when you get to the Virgo group, because as one object leaves the field of view, the other one's already coming in the field of view. Also, it's easier to star hop when you have a little bit wider field of view. I've used telescopes with my 6-inch telescope I've been able to use with a 1.8 degree field of view by adapting, I don't have the picture here, but I adapt a 2-inch eyepiece to the 1 1/4 inch draw tube. Now, how do I match those two together? I use a plumbing fixture made out of rubber with a hose clamp on it. And the 2-inch eyepiece fits in the big end, and the hose clamp is tightened around the draw tube of the eyepiece holder. And I refocus it so that all the light that comes through that 1 1/4 inch focuser comes through the eyepiece. And so that's the maximum field of view you're going to get with your telescope with a 1 1/4 inch eyepiece, if you can do that. In fact, for my 10th comet discovery, I use that type of eyepiece setup with my 6-inch Criterion telescope. And I use that a lot for the Messier Marathon, 1.8 degree field of view.
Okay, and the flexible hose clamp, I assume that's Home Depot?
Home Depot.
Yeah, those are available at Home
Okay.
Depot. I was in that section just a couple of weeks ago.
I only know that because I bought a cell, the objective lens, a doublet on eBay, which I attached to a piece of PC pipe. Was it PVC pipe?
Yeah.
PVC pipe with a flexible hose clamp that I got in Home Depot. That's the only way I knew that.
Marianne wants to know what's the best way to get in touch with you. Do you have a contact link on your website, or do you just give out your email?
I do have a contact on my website, and also my email is dontheastronomer@gmail.com.
Okay, that's easy to remember. Don the Astronomer, all one word, Marianne. dontheastronomer@gmail.com.
And let me see if I have a picture here of that eyepiece. I don't have it offhand, but it's a plumbing fixture. And it's you attach it between your 2-inch eyepiece and the eyepiece holder.
All right.
You can do that.
I'd like to put in a plug for showing kids that are about 12 year olds, they're 12 years old, comets, because I had an experience with Hyakutake myself when I was down at Fremont Peak, and it really opened my eyes, if you'll pardon the pun. And that was, I had a 12-year-old boy looking through very large binoculars at the nucleus of Hyakutake, and he could see colors in it that I could not see.
Oh, wow.
And he was actually describing, oh, the colors are changing from this to this to this. And your color vision peaks when you're 12 years old. So for those of you that do outreach, next time you have a great comet, show it to kids. Do as much as you can to show it to kids, because that'll be it'll be an unbelievable, memorable experience for them. And I couldn't believe what he was describing to me, but I knew for a fact it was true because I'd seen images of it.
And yes, as the comet nucleus rotates, sometimes you'll get different appearance, but sometimes change in brightness too. Besides, I don't know if you can see this, but this is the rubber fitting here, and there's a 2-inch eyepiece here and a 1 1/4 inch draw tube there.
All right. Well, it looks as though we've come to the end of our questions. I will recommend people to, if they want to find Don's podcast, they can find that on our East Bay Astronomical Society group Facebook page. Don's been nice enough to work with us on that, and he'll be posting monthly a link to his podcast. His podcast is like an ephemeris for astronomers. And if you want to know what's going on that particular night or this particular week, it's a really great source. So when you get there, you might want to bookmark that.
Could I ask one last question?
Yeah.
Yeah. Don, when you spoke to us back at the old Chabot, you mentioned use of eye patches. I wanted you to just touch upon that briefly if you have a chance.
Excellent idea. Back in the early days, the two options were to squint, and I would read that your eyes can get tired if you're squinting. Besides that, I seem to be unable to close my left eye and keep my right eye open. I can do the opposite, but I can't do that. And the other thing is that usually then I would just put my hand over my unused eye and look through the eyepiece. Well, comet hunting for hours, you can't do that. So very early on, I began using an eye patch, and I use that all the time. Other options I've tried over the years is to put a box around the eyepiece, and then that keeps all the stray light out. I've also put a blanket over my head to keep out stray light. But the key is you've got to keep all of the light from entering one eye if you want to have the most contrast and the best image in the other eye.
Thank you.
In fact, when they sell telescopes, they probably ought to sell an eye patch with it, don't you think?
Yeah, it's a great idea. An observing hood is another possibility.
What's that?
An observing hood.
Oh, yes, observing hood, yes. I'm going to stop sharing now. Is that all right?
Yeah.
Yeah,
Yes. Well, thanks everybody for joining us tonight. Is there anything, Don, you want to add, or Dave?
Well, I just want to thank you for inviting me to talk about the Messier Marathon. It's a great thing to do, and you've got decades in order to get it done. So, you know,
Well, our pleasure.
Every late March, or actually any time of the year, you can do it. But
Well, it's been our pleasure. We're honored to have you.
oh, thank you, thank you.
Thank you very much, Don.
All right, you guys.
All
Take
right.
care.
Good night, all. Thanks for joining us.
See you next month.
Bye-bye.
Bye.